Now student, our third colligative property is depression in freezing point. Here the word depression means the decrease in freezing point. First of all, we understood the term freezing point. Freezing point, it is the temperature at which solid and liquid state of a substance coexist and they have same vapor pressure. That temperature is known as freezing temperature. Means वो टेम्परेचर जिस पर सॉलिड लिक्विड स्टेट किसी भी सब्सटेंस की एक साथ हो और उनका एक जैसा ही क्या हो, वेपर प्रेशर, देन दैट टेम्परेचर इज नोन एज द फ्रीजिंग टेम्परेचर. कंसीडर when non-volatile solute added to a solvent, then this solute occupy interparticle space that present between the solvent particle. When we decrease temperature, when we decrease the temperature, kinetic energy particles की क्या करेगी, decrease, as kinetic energy directly proportional to temperature. As a result, solute and solvent particles comes closer to each other and there is increase in the forces of attraction. As a result, they becomes solidify. But in case of solution, this solidification delay मीन्स वो इतना आसानी से सॉलिडिफाई नहीं होगा, जो उसका सॉलिडिफिकेशन का प्रोसेस है वो थोड़ा सा क्या हो जाएगा, डिले. क्यों होगा? ड्यू टू द प्रेजेंस ऑफ non-volatile solute. As a result, सॉलिडिफिकेशन का प्रोसेस डिले हुआ. तो इसका मतलब क्या है कि उसका फ्रीजिंग टेम्परेचर क्या हो गया, फर्दर डिक्रीज. एंड दैट डिक्रीज इन फ्रीजिंग टेम्परेचर बाय द एडिशन ऑफ नॉन वोलेटाइल सॉल्यूट is known as depression in freezing point. Now, as a result, temperature is further decreases even below the freezing point or freezing temperature of pure solvent, and therefore here we observe depression in freezing point, and this is graphically illustrated as graphical representation of depression in freezing point. In order to illustrate it, we plot a graph between vapor pressure and temperature. Again, we take the two curve. Here we plot a graph. In this axis we take vapor pressure and here we take the temperature denoted by T. There are the two graphs. One is like this, point A, this is point B and up to C. Second curve, here A, this point is D and it is E. Here the curve A, B, C for solvent and ADE, curve ADE for solution. As we move from C to B, what happens? Temperature in this direction goes on decrease. So when we move from C to B, temperature decreases. Particles comes closer. So forces of attraction increases, and when forces of attraction increases, then there is the start of the solidification process. It means at point B the solid and liquid state coexist. क्योंकि हमने क्या कहा, solidification start, complete solidification नहीं हुआ, वहाँ से start हुआ. It means B से right hand side liquid और B से left hand side आपके पास क्या हो जाएगा, solid. It means at point B solid and liquid states are coexist and they have the same vapor pressure and the corresponding temperature, that is TF naught is known as the freezing temperature of solvent. TF naught is the freezing temperature या freezing point of solvent. Now in the same way, when we move from E to D, further temperature decreases, kinetic energy of particle decreases, forces of attraction increases, again solidification takes place. It means at point D, solution exists in the two form, solid as well as in a liquid form, and the correspondingly they have same vapor pressure and the corresponding temperature, that is TF is known as freezing point or freezing temperature of solution. As freezing temperature of solution is less than the freezing temperature of pure solvent, therefore that decrease is known as depression in freezing point. Now we clarify the definition. The temperature at which solid and liquid state coexist at point B and at point D. B in case of solvent and D in the case of solution. At both point B and D, solid and liquid state, solvent and solution respectively coexist and they have the same vapor pressure and the corresponding temperatures are known as their freezing temperature. Justify the definition. Now the difference between TF and TF naught. is denoted by delta TF, and that delta TF is known as depression in freezing point. Now, depression in freezing point is also a colligative property. Now, explaining the colligative property. Colligative properties are those which depends on number of moles. Now, delta TF is a colligative property. Delta TF as colligative property. Experimentally, delta TF directly proportional to m. Here small m again is the molar concentration, that is number of moles of solute dissolved in 1 kg of solvent. Ma is the molecular mass of solvent in kg. Now replace the proportionality sign. Delta TF is equal to KFM. Here Kf is known as cryoscopic constant or molar depression in freezing point constant. Now we know m is equal to Nb over Ma. Here Nb is equal to given mass of solute Wb upon molar mass of solute Mb. Put these values here. M is equal to Wb Mb Ma. Ma in kg. If Ma in gram, now 1 kg is equal to 1000 gram. Here M is equal to Wb upon Mb Ma in gram in kilogram divided by 1000. Move on the above side. Now the expression becomes M is equal to Wb Mb Ma 1000. Move on the above side. So M equal to this. Now put this in equation 1. Put the value of M in equation 1. We get delta TF is equal to KF Wb 1000 upon Mb Ma in gram. Here delta TF is depression in freezing point, Kf is cryoscopic constant, Wb is the given mass of solute, Mb is the molar mass of solute, Ma is the molar or molecular mass of solvent in gram. This expression is also used to find out the molar mass of solute, that is Mb, after rearrangement. This move here, Mb is equal to Kf Wb 1000 upon delta TF Ma in gram. As from this expression we find that depression in freezing point depends on the quantities, given mass, molar mass, or it depends on the molar concentration, that is on the number of moles. So delta TF is regarded as the colligative property. Now some conceptual questions are also there. First question is, what do you mean by anti-freezing? What do you mean by anti-freezing solutions, or why anti-freezing solutions used or added to the car radiators. Why anti-freezing solutions are added to the car radiators or vehicles. As we all know, in car radiators, generally water is used as a coolant. The water circulate in the car radiator and cooling down the engine and increases the efficiency of the engine. But in hilly areas, where the temperature even less than the 0 degree Celsius, the water freezes, that used in the car radiator as a coolant. When it is freezes, so it is solidified and there is no circulation of that water in the car radiator. So there is no cooling. That decreases the efficiency of engine. So in order to avoid this problem, means to prevent the solidification of water in the car radiator, we mixes the anti-freezing solution in the car radiator or vehicles in the hilly areas. That decreases the freezing temperature of water, and by varying the amount of that anti-freezing solutions, we decreases the freezing temperature of water up to the desired extent. And one of the example of anti-freezing solution is the ethylene glycol, that is CH2OH, CH2OH. Its proper name is ethane 1,2-diol, that used as a anti-freezing solution. Now the next question. In cold countries, why NaCl, CaCl2 used to clear the snow on roads? Here the same reason, because they causes the depression or decrease in the freezing point of water to such an extent that water cannot freeze to form the ice. So there is no problem of the solid snow on the roads. Here the answer, because they depresses or decreases the freezing point of water to such an extent that water can't freeze to form ice. Now, thank you student. Have a nice day.